My name is
Kyle. You're on the way to the camera. Kyle, can you just for
I started researching the Doppler effect back in '69.
Kyle, you're not even that old. Kyle,
I
you're
graduated
17.
from Yale with a degree in music
No, you
theory.
didn't.
You can check my
You're
stats
still in
in
high
my
school.
schools.
Kyle, can you just shut up? Kyle, shut up. Shut up.
I've been alone with you inside my mind, and in my dreams I've kissed you.
Have you ever woke up in the middle of the night and wondered why your ex left you for some filthy scrub? And as they drove away from you in that Monte Carlo cursing at you, you noticed that their voice changed in pitch as they accelerated away from you? Of course you have, Carla! Maybe if you would have paid attention in physics class and not spent all your time cheating on me, you'd know why your pitch changed. This is a result of the Doppler effect, Carla. The Doppler effect is a change in frequency of a wave for an observer relative to its source. Carla!
What you just saw was an example of the Doppler effect. When the source of the waves, Limp Bizkit, is moving towards the observer, each successive wave crest is emitted from its position closer to the observer than the previous wave. Therefore, each wave takes slightly less time to reach the observer than the previous wave. The waves bunch together, making the noise a higher pitch. But if the source is moving away, the distance between the waves becomes greater, creating a deeper pitch.
But why do we get bored? And why does it matter? Evidence of being temporarily uninterested in...
So the final frequency is equal to the sound you hear multiplied by the speed of sound plus or minus the velocity of the detector divided by the speed of sound plus or minus the velocity of the source. A train moving at 60 meters per second has a whistle with a frequency of 300 hertz. If the speed of sound is 345 meters a second, what is the frequency heard by a stationary observer as the train moves towards him? The frequency will be 300, the velocity of sound is going to be 345, the velocity of the source is going to be 60, while the velocity of the detector is going to be 0. Because the train is moving towards him, it will be a negative number.
If the detector is moving towards the source of the sound, then the detector's velocity is positive. If the detector is moving away from the source, like it's going that way, then its velocity is negative. It's the inverse for the source. These are the fundamental rules you will need to know about the Doppler effect. Next time you hear a police siren go by, and you know why it makes that sound, you'll go, gee, Eric, does anybody else smell burnt toast? Well, you see, I would highly recommend that you should probably go see a doctor about that, okay?
Now the rest of you, yes, even you, will know my physics is rad.
Yeah.
Wow!